All right, Algebra 2, we're going to go ahead and work the quiz review together. I'm going to try to get as many of these as I can, so let's go ahead and do it. Number 1. Actually, I'll do number 1 and let y'all do number 2 on your own. So this is from the previous test. This is just normal factoring. We're going to start with labeling our A, B, and C. So I'm going to you can write this wherever you want to, y'all. I just need room. So my A, B, and C, and then my AC. What do I mean by that? Well, the A is the one attached to the x squared, which is 4. B is attached to the x, which is 29. C is the dangling number, which is 7. And then A times C is 28. So now, what multiplies to 28, but adds to 29? Multiplies to 28, adds to 29. I see there's both positives here, which means both my factors are going to be positive. And I know, by looking at this, 1 times 28 is 28. 1 plus 28 is 29. So now I'm going to go ahead and break this 29 up into different factors. And if you're completely lost on this, that means you haven't done anything. And go check 1013 and 1012 in the second 6 weeks for how to do this. Now I'm going to take the GCF out of both these parentheses. This first one is going to be 4x, which leaves me with x plus 7. You're wondering how I did that. Both these letters have x's. One of them is an x squared, one of them is x to the 1. I take out the smallest letter, and then I take the biggest number out that goes into both. In this case, it happens to be 4. So now I'm going to go ahead and look at this. This 1x plus 7, I can't take anything out. So since I can't take anything out, I always add that extra plus 1 right there. There's nothing to take out. And so now my factors are 4x plus 1 and x plus 7. And those are my factors. So that factor should go here. Now it wants you to solve it. That's the new stuff. How do we solve it? You take each separate parenthesis and you set it equal to 0 and you go. Take each separate parenthesis, set it equal to 0 and go. Now let's solve it. This is a normal equation now for all you who are like, oh my God, what happens next? Y'all, this is algebra. Go back to 7th grade, go back to 8th grade. There's no new math. So stop right now. If you're panicking on what to do with the step, stop, breathe, and then remember, this is just the basics. Now you're going to subtract 1 on both sides. On this one, 4x equals negative 1. Divide by 4 on both sides. And I end up with x equals negative 1/4. I'm out of room, so x equals negative 1/4. That's for one of my problems. So I'm going to scooch down a bit. Negative 1/4. And again, y'all, you don't have to be as messy as me. X plus 7 equals 0. I'm going to subtract 7 on both sides, and I end up with x equals negative 7. Done. Yeah, I think I'm going to let y'all do this other one. Remember the whole thing. Remember your ABCs. Get your ABCs in there, and you'll be good to go. So go ahead and do that one on your own. I'm going to go ahead and move to the next stuff. Y'all, really? Do I got to fill this out for you? These are the things you're supposed to have memorized. If you had your times tables down, you would have this memorized. But here we are. This is straightforward. This should be something you do in your sleep. And there you go. And eventually, we are going to talk about the plus minus stuff eventually, but not yet. Okay. That is the first part of this review. I'm going to go ahead to the next stuff. All right, number 13. Let's see what I got here. It wants me to basically create or simplify this as best as possible. So when I ask myself, how do I break this down? I'm going to break it down by essentially dividing this out until I find good numbers that go into it that are perfect squares. So what do I mean by that? I have 1 times 24. I have 2 times 12. I have 3 times 8. And I have 4 times 6. So check it out. 1 and 24 are not perfect squares. Well, 1 is, but we don't count that. 2 is not perfect square. 12 is not perfect square. 3 is not. 8 is not. But 4 is. 6 is not. So watch how I rewrite this. I'm going to rewrite this as the square root of 4 times 6. And then one more step. I'm going to split them apart. Square root of 4 times square root of 6. The square root of 4 is 2. And then I just shove them together at the end. And that's my answer. Same thing with 28. I'm going to split this up into 4 times 7. For those who are lost, 4 times 7 is 28. And then based on the rules of radicals, since these are multiplications, I can split them up into their own separate houses. Square root of 4 is 2. And then I can't do anything with square root of 7. Oh, with that. So there we go. Number 13, same process. Divide by stuff until you get stuff. In this case, 13, I know, is 16 times 3. So I'm going to go ahead and redo this as square root of 16 times 3. Mister, how am I supposed to know the numbers? Well, had you learned your times tables, you would know your numbers. That's how you're supposed to know them. So I recommend getting a times tables out, figuring that out. I really recommend you learning your times tables. That would be great. Anywho, that's that for number 13. Let's look at 80. What can I divide 80 into? There's 20 times 4. Let's do this. There's 1 and 80. There's 2 and 40. Is there 3 that goes in that? No. 4 goes into it. 20. Does 5 go into it? It does. How many times? That's 16. That looks good to me. 5 times 16 is 80. 16 is a perfect square, so I'm going to do that. So I have the square root of 16 times 5. And if you're lost, 16 times 5 is in fact 80. 16 is a perfect square, so I'm going to take these and break them apart. Square root of 16 is 4. And then I can shove them together at the very end. There you have it. There's that one. Oh, I'll circle this one as well too. Going to 15. 3 times the square root of 20. All right, y'all? What I recommend is breaking this whole thing apart. The reason why I'm doing it this way is because I want y'all to have skills of manipulation, meaning being able to manipulate the numbers when we get into more complex problems. I want you to understand how to do that. There's this prime factorization where you divide by 2s and 3s over and over, but it doesn't teach you how to use the radicals, and that's what I want y'all to learn. So 3 times the square root of 20. Okay, see how I broke apart my 3, and I'm separating them into simpler problems. Now I'm going to go ahead and break apart my 20. I know that the square root of 20 is actually the square root of 5 times 4. And based on the rules of radicals, when I have a multiplication inside here, I can break it apart into separate houses as long as I maintain that. And I have 3 times the square root of 5 times the square root of 4. Now these are a bunch of mini problems. You have to ask yourself, can I simplify 3? No. Can I simplify square root of 5? No. Can I simplify the square root of 4? Yes. And that gives me 3 times the square root of 5 times 2. Now at the very end, we have 3 little things we have to ask ourselves. Should we have a house? The answer is yes. What is inside that house? 5. Cool. What's on the outside now? I have a 2 times 3, which is a 6. 2 times 3 is 6. And then there we go. That's on the outside of the house. So let's see if we can do that one on 16. Now we're dealing with numbers, y'all. I'm going to break this apart. 4 times the square root of 18 times the square root of x to the 10th. Now, with the rules we learned yesterday, when there's an even number, and we take this for exponents, and we take the square root, all we have to do is divide that number by 2. So check it out for those who didn't do their videos, which, by the way, I'm still bitter about. Times 10 divided by 2 is 5. So when we evaluate it, when we take the square root, it ends up being x to the 5th. And when you do that, you evaluate the radical, it disappears. You don't keep it. I see a lot of kids who are like, hey, the square root of x10 is the same thing as the square root of x5. And that is bunk. That's ugly. That's not true. No, that's not right. So when you evaluate it, get rid of it. All right, I can't simplify 4 anymore. Can't simplify x to the 5th. Now I got to deal with this sucker in the middle. So I'm going to go ahead and rewrite this as the square root of 9 times the square root of 2. How do I know that? 9 times 2 is 18. You'll get better at this as you go forward. I can't simplify 4. Can't simplify x to the 5th. Can't simplify square root of 2, but I can simplify the square root of 9. Notice how I'm keeping all my work lined up so you can see it all pretty-ish with my handwriting. Now everything's evaluated. I can't do anything with the 4. The 3 is simplified. The square root of 2 is simplified. X to the 5th is simplified. Now I'm going to do this. I have a house. Of all these terms, what's in my house? Just a 2. My letters on the outside are x to the 5th. And then I have 3 times 4, which is 12. So x to the 5th is taken out, square root of 2, and then I'm left with 3 times 4, which is 12, which is this right here. Oh, covered up part of the problem. And there we go. All right, moving to 15. 6 times the square root of 75. Once again, y'all break it up. Oh my God, I don't know why you're breaking it up, because you're learning something new. One of the things y'all bother me with so much is that you panic as soon as you don't know what's going on. It's called learning. Learning sucks and it hurts and it's like confusing and you hate it and you want to quit. Like, get over yourselves. Just keep pushing through and then you'll be able to learn the material. And it's worthwhile. Okay, with that said, square root of 3. You see what I'm doing? I'm just breaking everything apart. I broke down 75 into 25 times 3. Type it into Desmos if you don't believe me. 25 times 3 is 75. I'm going to take the square root of that 25, which is 5. And then I can't do anything with that square root of 3. So now I'm at the very end. 6 is simplified. 5 is simplified. Square root of 3 is simplified. What do I need to do now? I'm going to put that 3 inside there. What's on the outside of my house? 6 times 5, which is 30. Done. All right, let's go ahead and do number 16, and this is the last one. And y'all, the quiz looks very similar to this. The difference is problems 1 and 2 end up being the very last problems on the quiz. But otherwise, if you can do this, you're good. I'm going to start by separating all my components of this thing into different whatever. X to the 12th. Cool. Did I separate it? There's a 5. There's 72. There's x to the 12th. Perfect. Now I'm going to do one more thing. The square root of 72. Can I break that up into stuff? I can, actually. I can break it up into the square root of 36 times the square root of 2 times x to the 12th. X to the 12th. Oh, Lord, yeah, I'm messing up. This should be under the house. There we go. Sorry about that. You see what I messed up on the last problem, too? Great. Yeah, that x to the 12th should be under the house. So I broke up the 72, which is 36 times 2. Can I evaluate this even number exponent? The answer is yes. When it's an even number, you divide by 2, which is 6, and then the house goes away. Now I'm going to go through this again. Can I evaluate the 5? No. The x to the 6th? Nope. The square root of 2? It's all simple. This one I can. This square root of 36. 5 times 6 times the square root of 2 times x to the 6th. So now my process, I have to reassemble everything. What's inside my house? Just a 2. Any letters outside of my house? X to the 6th. And then I have 6 times 5, which is 30. And there we have it. I'm going to do one more bonus problem for people who are like, oh my God, there's no odds. Check it out. I'm just going to add it here. For anybody who makes it to this place and actually turns in 17 on the review, I will do something special. I just don't know what yet. So if I had 5 times the square root of x to the 3rd, y to the 4th, let's say 70. Let's do 72 again. And it should have been the number first, but who cares? So I'm going to break this apart. 5 times the square root of x to the 3rd times the square root of y to the 4th times square root of 72. See how I did that? Now, the rules for even exponents is simple. You just divide by 2 and drop the little house. Let's split up this 72 into the square root of 36 times the square root of 2. And then this x to the 3rd. This is, when it's odd numbers, this is the thing you have to do. You want to subtract 1. Just watch how I do it. I'm going to bring down that 5. You're going to subtract 1 from that, which will give you the square root of x squared, times the remainder, which is x to the 1. So I broke that 2 and 1 apart from that 3. So now let's go through and evaluate all this. The 5 I can't do anything with. X squared, the square root of x squared is now an even number, so that 2 divided by 2 is 1, so I'm just left with x. The square root of x I can't do anything with, so it just stays. Remember, if there's that 1 is the same thing if there's nothing there, so don't panic. Where's your 1? It's just a placeholder. You don't have to have it. Y squared can't simplify. 36 can simplify, and the square root of 2 can't simplify. So now, let's put this all together. Do I have anything in a house? Yes, I have a 2. Got that. I have an x. Got that. Anything outside the house? Yes, I have an x outside the house. I got a y squared. Actually, let's put the y squared first. I got a y squared out the house. I got an x outside of it. And now I have a 6 times 5. I have a 30 outside of it. And that's it. What I like to do is break these problems into a bunch of mini problems. Once these are a bunch of mini problems, it's done. And the more you do this, the more you'll be able to navigate radicals in a more complicated setting. So good luck on the quiz tomorrow.